Okay, good morning. Good afternoon, class. Okay, today we are going to start a new chapter, which is chapter 3, matrices. So you have learned matrices in Form 4 or Form 5 mathematics, right? So it will be similar concept, but it will go further. So look at the analysis table, STPM analysis table. So definitely every year there will be one questions from chapter 1. All right, and you see that the question will give you some sort like 8 marks or 6 marks. All right, so there are a few years. Okay, it came out in part B. So just recently, last year, it came out in part B. So I don't think it will come out again this year, but who knows, right? So if it really come out in part B, then it's lucky, because this is an easy chapter that you must score. All right. So first, we will see some basic concept or some special terms in matrices. Right? So what is matrices? So it is number that arranged in a rectangular area is called matrix. So a matrix usually represented by a bold capital letter such as A, B, C, and etc. So for example, matrix A is 3, 0, 5, 1, 2, 6. Okay, so a matrix with m rows and n columns is called a matrix of order m by n. So remember, we read it as m by n, not m times n. All right. So or a matrix of dimension m by n. We can name it as dimension or order. All right. So for example, just now matrix A. So this one we call it row 1. This is row 2. All right, and this is column 1, column 2, column 3. Therefore, matrix A has 2 rows and 3 columns. So A is a matrix of order 2 by 3. So this is how we name a matrix. Okay, so each number in a matrix is known as element or entry. Means this one, 3, 0, 5, 1, 2, 6. They are elements or entries in an matrix. So an element in the ith row and jth column of a matrix A can be represented by a small letter A, Aij. So when we see Aij, we understood that it's the element in I row and j column. All right. So for example, this example, so matrix A. So A11 means the element in first row, first column. All right. So it's just 3. Now, first row, first column. So 3. So A12. So A12 is in first row, second column. So first row, second column means it's 0. Right? So A13 is first row, third column. So first row, third column. So number 5 is a 5. All right, and so on. So the rest you can fill out. All right. Okay. So number 5. We now look at some special matrices. So number 5A is column matrix. What is the meaning of column matrix? So column matrix is a matrix of order m by 1. So since the name is column matrix, means it has only one column and m rows. All right. And B, a column matrix is also known as a column vector. It's actually related to vector. For example, matrix B is 2, 1, negative 4. So B is a column matrix of order 3 by 1. 3 row for 1 column. Remember, we name the row first, then only followed by column. All right, so it's 3 by 1. And actually, this can be represent a vector. So we will learn vector in chapter 6. Yes. Then you will see this form again. So this is column matrix. Okay, the next one is row matrix. All right, so row matrix is a matrix of order 1 by n. Since the name is row, so it has only one row and n columns. So a row matrix is also known as a row vector. Means we write the vector in this way. But this one we seldom use lah. How we normally use this one. Okay, column vector. So this is one example of a row matrix. Now let's say matrix C is 2, 1, -4. So C is a row matrix of order 1 by 3. 1 row, 3 column. 1 row, 3 column. Alright, so the next one is the null, or we call it zero matrix. Null matrix or zero matrix. So null matrix or zero matrix is a matrix with every element is 0 and is denoted by a capital letter O. For example, you see, this is zero matrix. So inside all the elements are 0. And this null matrix is of the order 2 by 3. Right? So means that zero matrix can be any order as long as all the elements are 0. Then we call it zero matrix. Alright? And number 8 is the square matrix. Alright? So name the square. So you know what is square like. So if it is called the square matrix, means it is in the order m by n. It is the number of the row and the number of the columns are equal. They are the same. Then we call it matrix. Square matrix. Alright? For example, matrix E is... Oh, sorry. Okay. Alright. The cover drop. Okay. I want it to drop again. Alright. Okay. I hope it won't drop again. Alright. Let's see. Okay. Okay, let's continue. Alright. So the square matrix, m by m, means the number of rows and columns are the same. So we will use square matrix a lot in this chapter. Okay, so for example, matrix E is a square matrix. So you see it has 2 row, 2 column. Alright. Number 9, the diagonal matrix. This is something that you haven't learned in SPM. Alright, so remember what is the name, what is the meaning of diagonal matrix. Right? So diagonal matrix is a square matrix. It must be a square matrix. Alright? Where at least one of the element in the major diagonal, or we call it leading diagonal. Major diagonal or leading diagonal is not 0. And other elements all are 0. So it must be a square matrix. So I have 2 examples here. This is a 2 by 2 square matrix. This is a 3 by 3 square matrix. Alright? The major diagonal means this one. It must be from the left up to the right down. Not this one. Okay? Don't confuse. So this is the major diagonal. This is the major diagonal or leading diagonal. Alright? So you see that the question say there is the concept for diagonal matrix is the element in the major diagonal. The element in this major diagonal is not 0. At least one. At least one is not 0. But others all must be 0. Alright? So you see that this one both also not 0. This one 2 is not 0. 1 is 0. It's okay. As long as there is at least one element in the diagonal, it's not 0. Other than that, all must be zeros. Then we call it diagonal matrix. Okay? So this one have to memorize. Alright, number 10, identity matrix. I think you learn identity matrix also in Form 5. Alright, or we call it unit matrix. As you can see. Okay, and we call it, or we call it unit matrix. Again, it must be a square matrix. Actually, when we come to matrices, alright, both the question that we solve must involve square matrices. Only involve square matrices, then many operations we can do. Okay, if it is not square matrices, then we have restriction. So many of the operation cannot do. Okay, so identity matrix also a square matrix where each element on the major diagonal of a diagonal matrix is 1. So we normally represent this matrix by capital letter I. It's not 1, it's I. So for example, this is a 2 by 2 identity matrix. You see the major diagonal must be 1, cannot be others, and others all 0. This is a 3 by 3 identity matrix. You see the major diagonals all are 1, others all 0. All right, so we call this identity matrix. And number 11, symmetrical matrix. This is also something new for you, and this concept came out twice in STPM. So you see, diagonal matrix not checked, so you better memorize it. So what is symmetrical matrix? So symmetrical matrix is a square matrix with the element Aij same as Aji. Means that the element in I row J column will be same as the element in J row I column. All right, for all the values of Ij. So the major diagonals is also its axis of symmetry. The major diagonal. So it must be a square. It must be a square matrix. All right. So this is one of the example. If this is a 2 by 2 matrix, it's very simple. We show the major diagonal. So you see the opposite element are the same. Symmetrical. Let's look at 3 by 3. So this is a 3 by 3 matrices. So we cut the major diagonal, or we call it axis of symmetry. So after that, you compare. You see the opposite element must be the same. 2, 2 here. -1, -1. 3, 3. Yes. So this axis is like a mirror. Therefore, we call it axis of symmetry. Is it okay? So remember this concept, the symmetrical matrix. All right? Now let's go to the next page. So here are the 2 examples. Right, can see here? Yes. Okay, so here are the 2 examples. All right, for symmetrical matrix. So you see, it came out in STPM 2002. So after 18 years, it came out again last year. So I will discuss one, and both questions also actually quite similar. They are almost the same question. Only this element different only. See that? So I will discuss only one. All right. So you will. Yeah. Okay. All right. Hold on. Let me see. All right. It's okay. Okay. So I will only discuss one. So you will check. Okay. And see. All right. Okay. Let me get the piece of paper. Okay, let's see. Question STPM 2002. All right. So you see that the question asks you to determine the values of A, B, and C so that this matrix is a symmetry matrix. 5 marks. All right. So if it is a symmetry matrix, so first you determine the major diagonal. This one, right? Use red pen. All right. Major diagonal. This one. So this is a major diagonal. All right. And we say that the opposite elements are the same. Remember just now we say Aij same as Aji. All right. So look at this. This is element first row, second column. This one, first row, second column. All right. It must same as A21. A12 must same as A21. 21 means second row, first column. Second row, first column. This one. So means that of course this A and this A not the same. Okay. So A12 is A squared. A21 is 2A minus 1. Yes, from here, correct. So from here, you know that because this is symmetrical matrix, so these two must be the same. All right, so you get your A. All right, so it seems like you have a quadratic equation. All right, yeah, it's A minus 1 square. Right, A square minus 2A plus 1, yes. So therefore, your A is 1. All right, then the next element, next pair of elements which are the same will be B square and B. Right, so this one and this one same. So this one and this one same. So this is actually element first row, third column, A 1 3. So it must be same as A 3 1. Third row, first element. Right? This one not necessary for you to write lah. You are not necessary to write this thing. Just for you to more understand only. Alright? Okay. So this is B square. And this is B. So you get B square minus B equals 0. Factorize it. Don't simplify the B. Okay, factorize it. So you get two answers of B. Alright, B either 0 or 1. Okay, so the next pair, the third pair will be this one. Alright, so where BC will be equal to B plus C. Alright, so since we have two B, so we sub each one and see what happened. Okay, when we sub B equals 0, alright, so this is 0, this is C. When sub B equals 0, so 0 times C, 0. 0 plus C, C. So C equals 0. What happens if B equals 1? Alright, when B equals 1, so C times B, C. And this one is C, B equals 1, 1 plus C. Okay, so when C move here, 0. C move here, C minus C, 0 equals 1. So we call this contra. Okay, means cannot lah. Not acceptable lah. B equals 1. Alright, therefore, make a conclusion. Your A equals 1, B equals 0, and C equals 0. This is your final answer. So a question like this give you 5 marks. Alright? Okay, can see it? Okay, so so question 2 will be your homework lah. Later you go back, please complete question 2 lah. It's actually almost the same. Alright, but it just give you 4 marks only last year. Okay, so this is the meaning of symmetric or symmetrical matrix. Alright, next we go and see next one will be transpose of a matrix A. Transpose matrix. Okay, what is the meaning of transpose matrix? So the transpose of a matrix A is the matrix whose the rows are the columns and whose the columns are the rows of matrix A. That is, the rows and column are interchanged. Alright, and the transpose of A, we write it in this way. A T. A subscript T. Alright, so for example, let's say this is matrix A. With the element A1, A2, A3, B1, B2, B3, C1, C2, C3. So the transpose of A, see not A, T, the transpose of A will be the row become column. You see, first row become first column, A1, A2, A3. Second row becomes second column, third row become third column. We call this matrix is the transpose of matrix A. Okay, all right, 13. So 13, we will talk about upper triangle matrix and lower triangular matrix. So we will use this one when we go to find the inverse. So have to memorize also. Okay, what is the upper triangular matrix? So upper triangular matrix is a matrix where the entries below the leading diagonals are zeros. Alright? Forgot. for transpose and also upper triangular, all are equal matrix. They must be equal matrix. Okay. So same, when you have a matrix, so this is the diagonals, this is the major diagonals. So the upper triangular matrix means below the diagonals, you see this triangle. All right, all are 0. Others can. Others, are they 0 or not, doesn't matter. But below the diagonal matrix must be all 0. Below diagonals, all 0. And we call it upper triangular matrix. Okay? Means the upper part not 0. And whereas the lower triangular matrix is this one. Same, this is the major diagonal. So the upper part, all are 0. The lower part, all not 0. So lower triangular matrix. Okay? So remember what is upper, what is lower. Don't confuse these two. Okay, so basically these are the types of matrices that you must know in this chapter. Okay, so we will go to 3.1.1, equal matrix. The concept of equal matrix. So two matrices are equal if the order of the matrix are the same. So means both also same order. If this is 2 by 2, this one also must be 2 by 2. And each corresponding element in the two matrices are equal. Alright, so the two m by n matrix A and B are said to be equal. So we can write as A equal B. So this is the example. Right, this is the example. So you see, this is square root 4. Square root 4 means 2 corresponding elements are the same. This is 1, this is 1. 0.5, half, same. -1, -1, same. This is the concept of equal matrix. And we're using this concept to solve the equation. Alright. Okay, next we go to the operation. Alright, 3.1.2, addition and subtraction of matrices. This one you have learned in Form 5. Alright, so you should know how to add or subtract two matrices. So if matrix A and B, can see, okay. If matrix A and B are two matrices of the same order, yes, if you want to add or subtract two matrices, they must be same order. Alright, then the addition or the subtraction of matrix A and matrix B can be carried out by adding or by subtracting the corresponding elements in matrix A and matrix B. So this is one example. So I give you a simple one, not just 2 by 2. So A is this one, matrix B is this one. Find A plus B and A minus B. Can you do it at home? I don't have to show, right? A plus B means for A, the corresponding element, you just add the corresponding element. -2 add 8. -6 plus 9. 7 plus -5. Minus means 5 minus -3. You plus or minus the corresponding element. So you try at home. You just complete it. And number 2, for any matrices A, B, C, and O. Still remember what is O? O is the 0 matrix or null matrix. All the element inside is 0. So they follow 3 rules. Alright, they follow 3 rules. So the matrix addition is commutative. If we add two matrices, it's commutative. Commutative means A plus B same as B plus A. Alright, we call this commutative. And in the matrix addition is associative. What is the meaning of associative? It is A plus B. It means we add A plus B first. Then we use this sum to add to C. Same as we add B and C first. After add B and C, then we add to A. They are the same. So we call it associative. Alright? And C. 0 matrix has properties similarly to the real number 0. In other words, the 0 matrix is the additive identity. Additive identity in matrix algebra. Additive identity means any matrix, if you add to a 0 matrix, any matrix you add to a 0 matrix, of course they must be same order. It will be same as like A plus 0, same as 0 plus A. it still remain A. It won't change. All right, so we call it additive identity. So another way to say it is A plus negative A equal to 0. Means A minus A equals 0. Okay, so remember, for addition of matrices, they follow these 3 rules. It's commutative, associative, and 0 is the additive identity. Okay, huh? So we already discussed about addition and subtraction. Now we go to multiplication. Multiplication has 2. One is multiplication by a scalar, by a number. This one also very easy. Another one is the product of 2 matrices. This one different. All right. Okay, we look at multiple by a scalar first. So when the matrix A is multiplied by a scalar K, K can be any real number. So it means that each element in matrix A must multiply by the K. For example, K multiplied with matrix A means K multiplied, this is matrix A. So K have to multiply in each one. All right. So the matrix Ka is called a scalar multiple of A. Okay. So for the properties of scalar multiples, so we also have few rules that we can follow. Let's say H and K are any real numbers. A and B are the matrices of the order m by n, means they are same order. Okay, so A, K, H, A means we multiply H into A first, then only multiply K, same as, sorry, drop again. Okay. All right. I hope it won't drop again. Okay. All right. So again, first row is when H multiplied to A, then only multiply K. Same as we multiply K and H, then only multiply A. All right. It's something like associative. All right. Another one is K plus H multiplied with matrix A. We can split them, become Ka plus Ha. All right. So actually, this is something like distributive. I didn't mention here. So this is something like associative of multiplication. This is associative of addition. So this is associative of multiplication. And this is something actually called distributive. Distributive law. This is also one of the distributive law. K multiplied with matrix A plus B, same as Ka plus Kb. These two also distributive for multiplication. Okay, so matrix also apply this. Right, still can see it. Okay. All right, so this is multiple by a scalar. Because we have to know all these rules. The following operation that we are going to do actually follow all these rules. Without these rules, we cannot simply do any operation on matrices. Understand this? Okay, next will be the product of 2 matrices. How to multiply 2 matrices. This one also you have done in Form 4, Form 5 or SPM lah. But I think that time you only do for 2 by 2 matrices. Now you have to get used with 3 by 3 matrices. All right. So I will discuss this step quite details lah. Okay. So before this, let me explain something. You see, we have addition and subtraction of matrix. We have multiplied a matrix by a scalar, and we have product of 2 matrix. So you see, we don't have divide matrix. See or not? No division of matrices. So remember this. You divide a matrix by a number can. Or you divide a matrix by a number is actually from here, same concept. Means you multiply a scalar 1 over only. Or let's say you divide a matrix by K. Means that you actually multiply it by 1 over K. All right, but we don't have divide matrix with matrix. Okay, remember this concept. No division matrix with matrix. Okay, so let's go through how to multiply two matrices. Okay, if matrix A is a matrix of order m by p, it's order m by p, and B is a matrix of order p by n. So this one m row, p column. This one p rows, n column. All right, so the product of the matrix of AB will exist. Okay, and it's a matrix of order m by n. So from this concept, you know, not all matrices we can multiply them. Not all matrices can be multiplied together. Okay, they must follow this concept. What is this concept actually? Very simple, you see. This is matrix A, right, just now, and the order is m by p. And this is second matrix. The order is p by n. So you see, this one must be the same. The number of rows of the first matrix must be same as the number of columns of the second matrix. This inside one must be the same. Then only can multiply. Why? If you still remember, we are actually use the row in this matrix to multiply the column in this matrix. That's why they must be the same. Then only we can do it. Okay, so first thing must remember. So first, look at these two. Same or not? If same, can multiply. And what is the answer? So answer is AB. And what is the order of this product? Must be m by n. M by n. All right? So we use the principle row into column to obtain the product AB. Row into column means use all the row in first matrix, okay, to multiply the column in the second matrix. So we call it row into columns. All right, so this is how we're going to multiply two matrices. Okay, so let's go to the next page. Okay, so this is the table. So I will use one example to go through all this. So we don't have to see it here. Okay, so I will show one example to you. So let's say you are given matrix A, this one. Matrix B, this one. You are asking to find the product of AB and BA. Okay, so let's start. All right, so look at A. A is how many rows? 2 rows, 3 column. So the order is 2 by 3. Okay, how about matrix B? 3 rows, 2 column, 3 by 2. All right, so C, number of columns same as number of row. Okay, can multiply. All right, can multiply. So the answer, your answer, the product should be in the order 2 by 2. Then only correct. All right, okay, so let's start. So matrix AB, please copy. This one must write. Copy your A and copy your B. Okay, don't skip this step. I know some will say that, teacher, the calculator can help us. Yes, it's true. The calculator can help you to find the product. But for me, it's quite dangerous because once you key in wrongly, because many numbers you have to key in. Once you key in wrongly one, then all the answer wrong. So you better know how to do it manually. Okay, let's make a big bracket. Right, first time you do it one by one. First time. So next time, if you think you can do it faster, you can skip. All right. Okay, so remember, row in column, right? Row in column. So we will use the row in the first matrix. We only use row for first matrix and multiply with the column in the second matrix. All right. So now we are going to use the first row. Okay, to multiply the first column. Okay, first row multiply first column. And how to multiply? First element multiply first element. 2 times 1 plus second element multiply second element. 1 times negative 3. Alright? Plus third element multiply third element. 3 times 4. This is how to get the answer, the first element in your product. See? So after you have used your first row to multiply first column, so the answer will be A11. Then you are going to use the first row also, but multiply with the second column now. Okay? So because it is second column, so it's here. So same. First element multiply first element. 2 multiply 5. Plus second element multiply second element. 1 times 2. Plus third element multiply third element. 3 times 0. Okay. Right? This is the meaning of row into column. Okay. After first row have multiplied all the columns, now we go to second row. Okay. Now we go to second row. We are using second row again to multiply each column. Alright? So first element multiply first element. 1 times 1. Second multiply second. Negative 1 times negative 3. Third multiply third. 0 times 4. Okay? Then second row, second column. 1 times 5. Negative 1 times 2. And 0 times 0. Okay? Then you calculate. So this is 2 minus 3, negative 1. Negative 1 plus 12. Negative 1 plus 12, 11. This one 10 plus 2, 12, 0. Okay? 1 plus 3, 4. 5 minus 2, then 3. Yes, this is your product. Okay? Yeah, so this is a very detailed step. Okay, so I hope you can refer to this example. When you get use of it, when you already get use of it, you don't have to write it up like this. Or you can directly calculate. But you make sure you don't make careless mistake. Alright, so AB. So just now question also asks us to find BA. Alright, BA. So copy B first. 1, negative 3, 4, 5, 2, 0. And A, 2, 1, 3, 1, negative 1, 0. Okay, looks at the order. So this is 3 by 2. This is 2 by 3. So same, right? So can multiply lah. And your answer, your product should be a 3 by 3 matrices. So this one I will go faster. Alright? First row, first column. First row, first column. So 1 times 2. 2 plus 5 times 1. So 7. Okay? Then first row, second column. 1 times 1. 5 times negative 5. So 1 minus 5, negative 4. Alright? Then first row, third column. So 1 times 3, 5 times 0. So 3. Okay? Can follow it? Then second row, to each column. So negative 3, 2. Negative 3, 2 times 2, negative 6 plus 2. So negative 4. Negative 3 minus 2, negative 5. Negative 9. Negative 3, negative 9, 0. Okay. Then last row, each column. 4 times 2, 8, 0. Then 4 times 1, 4. This one 0. 4 times 3, 12. Then 0. Yes. So you see, this is A times B. A multiplied B is a 2 by 2 matrix. B multiplied A is a 3 by 3 matrices. Therefore, you can make a conclusion that AB not same as BA. Okay? Remember just now, addition is commutative. Here, just now we talk about this one. Remember? Commutative. The matrix addition is commutative. A plus B same as B plus A. This is addition. So from here it's clear. For multiplication, it is not commutative for matrix. But for numbers, yes. For numbers, 2 times 3 same as 3 times 2, right? Numbers, I'm talking about numbers. 2 times 3 same as 3 times 2, 6 and 6 ma. So for algebraic, for normal numbers, multiplication is commutative. But for matrix, multiplication is not commutative. This one must be, remember, okay? All right. So number 3, just now we have done this example, right? So from the above example, if A is a matrix of m by n and B is a matrix of n by m, then AB is a square matrix. Both also square, right? Just now 2 by 2 and 3 by 3. All right? And hence, AB not same as BA. Therefore, the matrix multiplication is not commutative. Just now addition, yes, commutative, but all right, but for multiplication, it's not commutative. Okay. Okay, number 4. For any matrix A exists only if A is a square matrix. A means A multiply A. Matrix A multiplied matrix A. It only exists if A is singular. If A is a square matrix. Or if A is not square matrix, cannot. Alright? If it is not square matrix, means, for example, this one. A, this is 2 by 3, right? A is 2 by 3. Another A also 2 by 3. So you see, not the same one. So how cannot multiply, right? So the product does not exist. Okay, so the product of matrix of two same matrix only exists if A is a square matrix. If square matrix can, or 3, 3, 3, 3, then can. So we form power of square matrix by defining like this. So when you have A square means A times A. A cube means A times A times A. You can either write as A times A times A, or A square multiply A, or A multiply A square also can. Alright? And if A to the power of 0, this is something like the real number, then it will become identity. Alright? So in general, if A is a square matrix and n is a positive integer, then A to the power of n means you multiply A itself by n times. Alright? So number 7, we also form polynomial in matrix A that is for any polynomial fx. For any polynomial you have learned in chapter 1, right? Let's say this is a polynomial. So if we sub matrix A into this polynomial, alright, and we find that the FA equals to 0 and you get 0 matrix. When you sub matrix A into this polynomial and you get 0 matrix. So means that FA is a 0 matrix. Then A is the 0 or root of the polynomial fx. Alright, so when we talk about polynomial, we are not only talk about numbers, we also can apply this to matrix. Later you will see there is a past year question related to this concept. Okay, so let's continue a little bit. Then we will go to some question. Then we'll stop for a while. Okay. All right. Properties of matrix operation. This is something like we repeat what we have done just now, So
Can see. Okay, still can see it.
all right. So properties of matrix operation. So for any matrices A, B, C, and the null matrix of the same order, all are square matrices. You see, these properties apply to all square matrices only. And the sum and product of matrices are defined. So means can find. All right. So there are altogether 6 properties that you should know. Number 1, addition of a matrix is commutative. A plus B same as B plus A. Additional of matrix is associative. We add B and C, then only add to A. Same as we add A and B first, then only add to C. Multiplication of a matrix is not commutative. Just now we have proved it. And multiplication of a matrix is associative. Associative can, but not combinative. Means we multiply BC first, then multiply to A. Same as we multiply AB first, then only multiply to C. You see the sequence still the same. ABC, ABC. The sequence still the same. But this one different. This one they reverse. Even though they are square matrices, but the answer not the same. Alright? And number 5 is multiplication of a matrix is distributive over addition. Distributive over addition means this one. If you A multiply B plus C, then same as AB plus AC. Only distributive over addition, not subtraction. Okay? Okay, others will be if multiplied with K lah. Alright, so K can multiply to the product of AB. Same as I multiply K to A first, then only multiply to B. Also same as I can multiply K to B first, then multiply to A. Means the K you can put anywhere you want. K is a number. Okay, OA same as AO, which is O. Okay, all matrices multiplied with the null matrices with the same order, you get null matrices. And for any square matrix A of order m by m, the product of A with an identity matrix I of the same order result in the matrix A. It is like this. Means any matrix multiplied with the identity matrix with the same order, you will get back A. It won't change the matrix A. Alright? So in other words, the identity matrix I is the multiplicative identity in matrix algebra. Just now we have additive, right? Additive identity means A, any matrix A plus 0 matrix, you get back A. For multiply is I. Alright? Okay. So far until here, you have learned all the important concepts that involve when you want to do operation on matrices. Okay? Alright, next we will see example 3.1. Alright, so checkpoint 3.1, you do question 1 to question 10 as your homework. Alright? I will discuss some questions here. Okay? So we start with a few questions. Alright? We start with a few questions with 2 by 2 matrices first, which is easier lah. Okay, so can see. Okay, can see it. All right. Okay, so question 2. If D is a diagonal matrix, so you are asking to find D square, D cube, and hence deduce D power n. All right, so this is D. D is -2, 0, 0, 3. Okay, D square means D multiply D because they are square, so can multiply. So same, first row, first column. So -2 times -2, +4. This is 0. So first row, second column, 0, 0. Second row, first column, 0, 0. All right. Then second row, second column, 0, 9. All right. So I left this later. We will use this one to find the answer. Okay. Okay. Then d cube. All right. So d cube means d multiplied d 3 times. But since I already have d squared, okay, so I use d squared times d lah. Okay. All right. So d squared times d. So same. First row, first column, negative 8. All right. First row, second column, 0. Second row, first column, 0. Second row, second column, 0, 27. All right. So how we are going to use d squared and d cube to d squared and d cube to deduce dn. All right. I give you 1 minute. You think of it first. Oh, sorry. You think of it first. Okay. Oh, sorry. Okay. All right. So you actually can see when it is square, this is 4 and 3, 4 and 9. So it's actually 2 square and 3 square, right? When it is cube, it is 8 and 27. You see, this is actually 2 cube and 3 cube, right? But there is a negative here. Doesn't matter. It's actually same as, it's actually negative 2 square, 0, 0, and 3 square. But else this one is negative 2 cube, 0, 0, 3 cube. Means this one, the base is negative 2 and this is 3. Therefore, we can deduce d to the power of n, which is negative 2 to the power of n, 0, 0, and 3 to the power of n. Yes, they like to ask questions like this. Okay? All right, then question 3. Given A, this is matrix A. So you're asking to find the numbers m and n such that a squared plus mn plus ma plus ni equals to 0. It seems like you are given a polynomial, right? An equation, but in matrix. Where I and O are respectively the unit matrix and the zero matrix of dimension 2 by 2. Okay, then using this relationship, find A cube and inverse A. Remember this, Okay, this is inverse A, not, doesn't mean 1 over matrix A. Remember, just like I said, we have no division of matrices. Okay, this is the inverse of A. I hope you still remember what is the meaning of inverse of A. We will go into inverse of A later. So I hope you still remember the concept of inverse A. Okay, so how to answer question like this? I can't remember. I think form 5 also you have question like this one. Okay, so this is matrix A given. All right, then we copy the equation given. Then just sub in your matrix A. A square means AA, M multiply A, N multiply I, identity matrix, equals to 0. 0 means this one. I write 0 first because not enough space. Okay, so multiply A and A. So same. First row, first column, 1 plus 6, 7. First row, second column, 2 minus 8, so negative 6. Then second row, first column, 3 minus 12, so negative 9. And second row, second column, 6 plus 16, so 22. I calculate wrongly, it's supposed positive 22. Then m multiply in. Just now we say multiply with the scalar, right? So m have to multiply into each. Okay, n also have to multiply into each. All right. Then the left hand side, I add all the corresponding terms lah. So 7 plus m plus n. Right? Negative 6 plus 2m plus 0. I add all the corresponding equal to 0. So I write this. Okay, so just now remember we learned the concept of equal matrix. Equal matrix. So because they are equal, so the corresponding terms also same. Alright, so I choose this one first. This one. I choose element first row, second column. First row, second column, this one. I compare them. This one, compare this one to this one. So I get m. Right? Then I use first row, first column, this one. So I compare this one and this one. So m I already have my. So I get my n. See? This is how we get m and n. Alright? So after we have done, the question wants us to use this relationship. Use this relationship. Find a cube and inverse a. Alright?
Still can see? Yep.
Use this relationship. We sub in the value for m and n. Alright? How to find a cube? A cube means I need another a here. So I can multiply the whole equation by a. I only can do this step. Multiply the whole equation by a. I only can do this step if a is square. Remember just now we say, if a is a square matrix, then only we can do this step. If a is not square matrix, we cannot do this. Remember this. So multiply matrix A to everything. So a square become a cube already. This one 3a square minus 10ia, 0 times a. A cube is what we want. 3a square. So a square just now we got from here already. Just copy. Identity multiply with a, just a only. Anything multiply 0, 0. Okay? So we just rearrange this one. Here. So a cube equal to, so I left hand side, I multiply 3 inside, multiply 10 inside, then I plus minus them, I get this. Alright? Then this whole matrix shift here. So this is your a cube. Okay? Alright. Now this is how to find a cube. Okay, next is how to find the inverse. Alright, how to find the inverse. So use the same relationship. Multiply the whole thing by the inverse of a. Same. We only can do this step because a is square. Alright? So this one, a square is a, right? Multiplied with inverse a. So 3a multiplied with inverse a. Now minus 10i multiplied with inverse a. Actually 0 also multiplied with inverse a lah. So you see for each term, I write inverse a all at the right hand side of the term. Right hand side of the term. It must be the same. You cannot say that I write inverse a for this term, I write inverse a here. For this term, I write inverse a here. I cannot. Okay? It must be multiplied to the same position. Remember this, Okay? So, after that, remember, in Form 5 you have learned, when a matrix multiplied with its inverse. When a matrix multiplied with its inverse, you will get identity. You have learned this concept in Form 5. Of course, later we will go through this again. Alright, so you see, when a matrix multiplied with its inverse, I get identity. Alright? Any matrix multiplied with identity, you get back the matrix. Alright? Okay. So this one become AI. This is 3i. Minus 10i, I shift it here. This is 0 lah, This is 0. So minus 10i, I shift here become 10 inverse. Because any matrix multiplied with identity, you get back the same matrix. Alright? So I just rewrite only. So 3i and AI. A multiply I still A. 3 multiply I is like this. Okay? So 10 can shift. Number can shift. Okay? Matrix cannot shift as divide, numbers can. So this is after I add, then you get your inverse A. This is another way to find the inverse matrix lah. Okay, so next will be question 4. Question 4. Okay, show that A is 0 for this polynomial. Remember the concept of polynomial? They want you to show that matrix A is a 0 for this polynomial. Alright, so this is matrix A. Okay, this is the polynomial. To show that it is the 0, you sub matrix A into the polynomial. All the x become matrix A. Alright, so AA, 2A, 11I. A multiply A, you get this. This one, you get this. Minus. So after I calculate, you can calculate. You get this. You get a 0 matrix. So when I sub matrix A into the polynomial, I get 0 matrix. Then you can make conclusion A is a 0 of Gx. This is how we show this part. Alright, show it is a polynomial. Then subsequently evaluate A cube and inverse A using this relation. Same as what we have done in question 3 lah. So this one I want you to complete at home. To find A cube and inverse A. Same like just now. Okay, next. Question 5. Alright, next question 5. Alright, next question 5 is this one. You are given matrix A. Find A squared, find A power 4, then find A power 23. It's a type of question that also came out in STPM before. Okay, so how to do it? A squared and A power 4, no problem lah. So this is matrix A. So this is A squared. A multiply A. So like this. A power 4, I write as A squared times A squared lor. So I have A squared already ma. So A squared times A squared, I get this. And I see the identity here. So I take out the 16. I can factorize out the 16, become like this. Alright, so 16 is 2 to the power of 4. So this is I, right? So how to calculate A to the power of 23? So A to the power of 23, because I already have A power 4. So I can say it is A power 4 to the power of 5. Right? Power 4, then power 5 again is 20 already. 20 multiply A squared and A. So 20, 22, 23. So we can rewrite A power 23 in this form. Alright, now we sub in. So A power 4 is this one. 2 power 4, I. Then this whole thing, power 5. This is your A squared. This is your A. Alright, so 2 power 4 and power 5 again. 2 power 20. And I power 5. Okay, this matrix multiplied this matrix, you get this thing. Okay? And I see 8 and 8, so I factorize out 8. Then this one become like this. Why I factorize out 8? Because I see that 8 is 2 to the power of 3. Alright, so 2 power 20 times 2 power 3 is 2 power 23. And multiply with this. This is your A power 23. Alright, so we are using concept like this to solve this question 5. Alright? Okay. Okay, the next one is STPM 2008. Actually, I want you to do this by using the multiplication word method, but it's actually quite long. It has other method to find it, you see. By right, it's an A. From A, we actually can find this. So I skip that one, but no need lah. Because using the multiplication method, it will be very long. So never mind, we skip this. Later, we will discuss this question again in the later part. Alright? So we go to the next one. Oh, okay. Okay, I will discuss one more question, 7. Okay, then we will stop for a while. Okay, we will stop for a while. Okay, so I will discuss one more, question 7. Because what we have discussed just now all are 2 by 2 matrices. We see 1 3 by 3 matrices. Or STPM question normally involve 3 by 3. Or they seldom ask 2 by 2 anymore. Okay, this is STPM 2004. Alright, so matrix P and Q, given that PQ and QP are the same. By right, just now we say PQ and QP not the same, right? But this is, the question tell you they are the same. Then we say they are the same. If the question never say, you cannot assume they are the same. Remember, we say multiplication of matrix is not commutative. But if the question tell you they are the same, then we use. Alright? And you are given matrix P and matrix Q. Alright? So you're asking to determine the values of ABC. The value of ABC here. Alright? After you get ABC, then you see you're asking to find the real number Mn for this polynomial. This is like what we have done just now, right? But that one is 2 by 2, now it's 3 by 3. Okay? Because it's involved multiplication of 3 by 3 lah. So I give you another one. Okay, so start with PQ same as QP. So please copy please copy PQ, QP. Then same lah, it just more step lah, just be very careful. First row, first column. 2 times -2, -2. This one is 0, 0. Alright? First row, second column. 2 times 1, 2. 0, 0. So 2. Okay? Last, this one and this one. 2 times 0, 0. -2 times -1, 2. 0. So 2. Same like others. So I explain the last row lah. Last multiplied last. So -a lor. All this 0. Okay? This one -a, 0, minus 2c. 0, minus b, plus 2c. Okay, no? So same thing like this. You multiply them and you get this thing. You try and calculate, see whether can get what I show here or not. You must try to calculate, Okay, now I compare element 2, 1. Element second row, first column. Second row, first column. This one. So this one and this one. So -a, same as 0. A 0, so I get A already. Then I compare element 2, 2. Second row, second column. Second row, second column. This one. So this one. So -b, same as -4. So b equals 4. Then I compare element 2, 3. Second row, third column. Second row, third column. This one. So compare this one to this one. So C equals 94. Alright? So this part give you how many marks just now? 5 marks. 5 marks. Okay, then we solve this one as usual. Okay, you are given this polynomial. So just sub in your P and Q. Of course, sub in all the ABC. Then you calculate right, left hand side. Multiply in. Alright, then you again you compare. So I compare element 1, 2. First row, second column. First row, second column. This one. So compare this one to this one. So M equals -2. Alright, then I compare E2, 2. Element second row, second column. Second row, second column. This one. So compare this one to this one. N equals 0. Okay? I don't know why they give you 5 marks or so lah, you see. Okay, so you see they give you 5 marks, so means you must show all these detailed steps lah. Please don't jump lah. You show all the detailed steps. Okay? Okay? So as I say lah, if you really ask matrix in STPM, it's not that difficult. So this is a chapter that you must score. Alright, it's a long lesson today. Okay, so we will stop for a while. So what I want you to do is, you do it now. Question 8 and 9. Alright, question 8. Given you matrix PQ, find integer m and n. It's not difficult, right? Alright, then find question 9. Do question 9, STPM 2003. Given matrix A, find matrix B if B is A squared minus 10i. Yeah, just use this one to find B lah. 3 marks. Okay, then you see this is a little bit challenge part, but actually not difficult. You get a B here already, right? So you're asking to find A plus I, then multiply B. So you add matrix A to identity. After you get the answer, you multiply to B. When you see the answer, you check. When you get the answer for this one, you check. It is actually same as something. You check. You check. Okay? Then you do another step. A plus I squared B. Alright? Then you do 3-4 steps lah. Then you can make conclusion for this one already. You try first. Alright? So I will give you about half an hour lah. Alright? You take half an hour to finish these 2 quiz. Then same, after that, snap the photo of your solution and put into the Google Drive that I give you. Alright? There are many questions inside there. So please name your file. Name your file. Okay? You can just write M1. So I know that this is the first quiz for chapter 3. Or M1, matrix 1. Alright? Okay, so we stop for a while here. Okay, later, after half an hour, I will send another video for determinant. Today, we have to finish until determinant. Okay, see you later.